Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, welcome you all in Pakistan International School Taif Virtual Learning System. Today is our 28th video lecture for grade 2nd year students, boys and girls. I am Mrs. Rosia Imran, your mathematics teacher. Today we will start a new topic, exercise 2.9. But before starting exercise 2.9, first we discuss increasing and decreasing function. That what is increasing function and what is decreasing function. Increasing and decreasing function, you can check it on page number 104 on your textbook. So let f be defined on interval AB, means that if you have any function f and its given interval is AB, and let x1 and x2 belong to AB, means x1 and x2 are the values of the function which belongs to this interval AB, then f is increasing, means that the function will be increasing function on the given interval if f of x2, function of x2, is greater than f of x1, means that where x2, whenever x2 is greater than x1, function f of x2 is greater than f of x1, then we say that function is increasing in the given interval. Similarly, if f is decreasing on the interval AB, if f of x2 is less than f of x1, here look, change, f of x2 greater than f of x1, so increasing function, f of x2 is less than f of x1, decreasing function, where this statement is same, x2 is greater than x1. You have given theorem on page number 105. These two theorems explain the increasing and decreasing function, and then how you can find the function that in which interval it is increasing and in which interval it is decreasing. Let f be differentiable on the open interval AB, means that when you take differentiate with respect to the given variable, the function, when you differentiate in the given interval, f is increasing on AB, means that the function will be increasing. AB is what? The given interval. In the given interval, if its first derivative is greater than 0 for each x belong to AB, means that for all values of the given function, if its first derivative is greater than 0, so the function will be increasing on the given interval. If the first derivative f prime of x, means that when you differentiate the given function, if its value is less than 0, then the function will be decreasing on the given interval. Similarly, you can check the first question is related to this. So first we will do that, and then how to take the first derivative test, that we will do for the next question. Then I'll discuss with you. First come to the first question. Look at the question. Determine the interval in which f is increasing or decreasing for the domain. Means that here you have not given that the given function is increasing or decreasing. Just interval is given, that in the given interval you check that the given function is increasing or decreasing. The function is what? F of x is equal to sine x, and the interval is minus pi to plus pi, means that minus 180 degree to plus 180 degree. So on this interval, you have to check that the function is increasing or decreasing. Look at the function. F of x is equal to sine x. This is already given. X belong to minus infinity to plus infinity. If you look at these quadrant, this is first quadrant. Here cos x is greater than 0 and sine is pi by 2. So this is 90 degree and this one is 0. This is 180 degree, and here 270 degree, and then 360 degree. First quadrant, in first quadrant cos x is greater than 0, in second cos is less than 0, in third cos is less than 0, and in fourth cos is greater than 0. So this is pi by 2, positive pi by 2, and this one is negative pi by 2. So given function is what? F of x. So first we differentiate this function. When we differentiate, so f prime of x, derivative of sine x, differentiate with respect to x, the derivative of sine x is cos x. Now what we will do to find the increasing and decreasing function? Look, you have to check it for 0, that the given derivative, the function, given function derivative is greater than 0 or not. So what will we do? F prime of x is equal to, put f prime of x is equal to 0. So you put the value of prime of x, which is cos of x equal to 0, where x value is minus pi by 2 and plus pi by 2. How? Look, this is cos of x. With your calculator, when you shift cos on other side, that will be cos inverse. So when you find it from your calculator, cos inverse 0, that is equal to 90 degree. Okay, so 90 degree is what? Pi by 2. So minus pi by 2 or plus pi by 2, because the negative sign in cos absorb. So minus pi by 2 or plus pi by 2. This you will get that x is minus pi by 2 and plus pi by 2. So we have sub intervals. Look, from minus pi it started to positive pi. So minus pi by 2, because this we already find it from this cos x equal to cos inverse 0, which is equal to this. So minus pi by 2 or minus pi by 2 to plus pi by 2 and plus pi by 2 and with pi. So we put this value in this interval. So we get these subintervals. Now f inverse cos x is less than 0 when x belong to this interval. How? Look at this quadrant. The first interval, subinterval is what? From minus pi to minus pi by 2, this one, the third quadrant. In third quadrant, you can check it. Cos inverse is less than, cos x is less than 0. Cos x is less than 0. Now check it, the second. So f is decreasing on that interval. Now check it, the other one, f prime of x, means the first derivative of the function is equal to cos x, which is greater than 0 for the second interval, minus pi by 2 to pi by 2. Look, from minus pi by 2 to pi by 2, cos x is greater than 0. So means that the function is increasing in this interval. Now we check it for the third one subinterval, that is cos inverse is greater than 0 from positive pi by 2 to pi. Here in this, cos x is greater than 0 in first quadrant. So this is increasing for the increasing function for the third sub interval. Fx is decreasing only when pi by 2 pi. Now look at the second part. In second part, you have given f of x is equal to cos x, and the given interval is minus pi by 2 to plus pi by 2. So we differentiate cos x derivative. We take the derivative of the function minus sine x. We put the first derivative is equal to 0. So minus sine x equal to 0, which implies that sine x equal to 0. And when shift sine on other side, so what will you get? X is equal to sine inverse 0. Find sine inverse 0 is 0. So means that the x sub interval is, for the sub interval is minus pi by 2 to 0 and 0 to pi by 2. From where you get this sub interval? Look, when you find the first derivative, after first derivative, this first derivative you put equal to 0 and shift this very the trigonometric function on the other side. Cos on other side, it will be cos inverse 0. So cos inverse 0 is infinity. So minus 90 degree or plus 90 degree. So the given interval is minus pi to pi. So subinterval is minus pi to minus pi by 2, and minus pi by 2 to plus pi by 2, and plus pi by 2 to plus pi. So from this you will get the subinterval. Similarly, in second, if you check, you take the derivative of the function cos x, you will get minus sin x. Now you put the first derivative equal to 0. So minus sin x equal to 0. Minus sign cancel, because when you shift it at other side, multiply with 0, you will get the same 0. So sin x equal to 0. Now shift this sine inverse on the right hand side. It will be x equal to sine inverse 0. So sine inverse 0 is 0. So 0. So the given interval is minus pi by 2 to plus pi by 2. The subinterval will be what? Minus pi by 2 to 0 and 0 to pi by 2. These are the subinterval. Now for both interval, we check this function. Minus sin x is greater than 0 for this interval, because minus pi by 2 and 0 in that is the fourth quadrant. So f of x is increasing on this, and first derivative minus sin x is less than 0 for 0 to pi by 2. So that is the decreasing function for this interval. So look at the third part. In third part, you have given f of x is equal to 4 minus x square, and the given interval is minus 2 and 2. Look, when you put minus 2 in place of x, you will get 0, and when you put plus 2, you will get 0. So the given interval is minus 2 to 2. So you differentiate. The derivative of 4 is 0, and derivative of minus x square is minus 2x. Coefficient power will come in coefficient, and from power you subtract 1, so you get minus 2x. Now the first derivative is equal to 0. So minus 2x equal to 0. Now you have to find the value of x from this. Minus 2, multiply here, shifted at other side, divide, so you will get x equal to 0. So means that for subinterval from minus 2 to 0 and from 0 to 2, these are the subinterval. So we check it for the first subinterval. Look, f prime of x minus 2x greater than 0 whenever x belong to minus 2 and 0. How? When you put minus 2 in this, you will get positive 4, which is greater than 0. When you put 0, 0 is equal to 0, so means that this interval is increasing. In this interval, the function is increasing. Now minus 2x is less than 0, where x belong to 0 and 2. So when you put 2, you will get minus 4, and minus 4 is less than 0, so means that f is decreasing on this interval. So similarly, you will do the fourth part. How? First you differentiate this given function. When you differentiate, you will get f prime of x equal to you put f prime of x equal to 0, so you put the value and find the value of x. 3 is positive here, shifted at other side, negative. To multiply with it, shifted at other side, divide. So the subinterval is from minus 4 to minus 3 by 2, and from minus 3 to 3 by 2 to 1. So the function will be decreasing in the first interval and increasing in the second interval. Now, before going to question number two, we have to find that how can we find the minimum and maximum value. Look, for this first derivative test, we will do first derivative test. Let f is differentiable in neighborhood of c, where f prime of c is equal to 0. The function has relative maximum at x equal to c if its first derivative greater than 0 before x is equal to c, and first derivative is less than 0 after x is equal to c. The function has relative minimum if its first derivative is greater than 0. Check it. Maximum when its first derivative less than 0, minimum when its first derivative greater than 0. Then second derivative test you will do. First, differentiate function for the constant, then f his relative maximum at c if its second derivative less than 0, and minimum when its second derivative greater than 0. Now come to question number 2. How can you solve it? Look, you have given in the find the extreme value for the following function defined is. You have to find the extreme value for these function. Look, what will you do? You follow these steps for all. Function is f of x is equal to 1 minus x cube. So you differentiate with respect to x to find the first derivative. F prime of x, derivative of 1 is 0 and derivative of minus x cube. So 3 will come in the coefficient, and from power you subtract 1, 3 minus 1, 2. So minus 3x square we get. This is the first derivative. Now for stationary point, what will you do? You put the first derivative is equal to 0. You take minus 3x square equal to 0. Minus 3 multiply here, shifted at other side, divide. So x square equal to 0. When you take square root, so x equal to 0. Now differentiate again the first one. You find the second derivative. Here the power will come in the coefficient. So 3 2s are 6. And from power you subtract 1, 2 minus 1 x. So minus 6x we get. Now again you put x equal to 0 in the second derivative. So minus 6 into 0 you will get 0. So second derivative test fail. To determine the extreme point from second derivative, again we get 0. So means that it is failed to find the extreme point, because when we solve the other function you will check that from second derivative we will get some constant value, but here we get 0. So means that second derivative test failed. When second derivative test fail, to find the extreme points, what will you do? You put x is equal to 0 minus epsilon. So this epsilon is a very small value, approximately negligible. So in the first derivative, you put minus, in place of x, you put minus epsilon. So minus 3 minus epsilon square. So you get minus 3 epsilon square, which is less than 0. Then for the second x you put 0 plus epsilon. So when you will get the same answer, less than 0. So f prime of x does not change its sign before and after x. Means that when you put the value of x, the negative epsilon or the positive epsilon, the function, the first derivative does not change its sign before and after. So since at x, f of x is equal to 1, therefore 0 1 is the point of inflection. So 0 1 is the point of inflection. You didn't get that the given function is maximum or minimum. Look at the second part. In second part, you have given x square minus x minus 2. Same steps we follow. We take the first derivative. So it will be 2x, and for minus x minus 1, and for constant 0. So you will get 2x minus 1. So you put the first, for stationary point, you put first derivative is equal to 0. So 2x minus 1 equal to 0. So 1 shifted at other side positive, and 2 multiply with x shifted at other side divide. So we get 1 over 2. For stationary point, x is equal to 1 over 2. On this value, we have to find the function is minimum or maximum. If you check in the first, we get 0. That's why we didn't find any point which give the extreme value. So we second derivative test is also fail. So what we done, we put some negligible value, very small value, 0 minus epsilon and 0 plus epsilon, and we get that the function is not maximum or minimum, therefore 0 1 is the point of inflection. But in this we will get the point is minimum or maximum, because the first derivative, when we put equal to 0, we get the value of x. Now we differentiate again the first. So we get the second derivative 2x. So it will be 2 and the one derivative is 0, so we get 2, and 2 is greater than 0. How? When you put in second derivative 1 over 2, there is no x in the function, in the second derivative function. If it is x present, so we put this value in that, but here is no. So 1 over 2 for second derivative 1 over 2, this function 2 is greater than 0, so therefore f of x is minimum, because second derivative is greater than 0, so minimum at x is equal to 1 over 2. So given function f 1 over 2, 1 over 2, in place of x you put its value 1 over 2 square minus 1 over 2 minus 2. When you take LCM, you get minus 9 over 4. Now come to the third part. In third part, you differentiate this function with respect to x. So what will you get? 5 twos are 10, and from 2 you subtract 1, so 10x, and minus 6, because dx by dx is 1, and constant derivatives. So now this 10x minus 6 is equal to 0. First derivative for stationary point, for value of c, we put it equal to 0. So 6 subtracted here, shifted at other side, divide, and 10 multiply with x, shifted at other side, divide, and we get divide by 2, numerator and denominator, so we get 3 over 5. This is the stationary point. This 3 over 5 we put in place of x when we find the second derivative. So you differentiate 1 again with respect to x. So what you get? 10 dx by dx. So 10. So there is no x. So 3 by 5 for we put for the second derivative. 10 is greater than 0. So therefore function is maximum at 3 over 5. If this value is less than 0, then maximum. If it is greater than 0, then minimum. So minimum, now you this 3 over 5 you put in the given question in place of x, 3 by 5 whole square, and minus 6, 3 by 5 plus 2. So 3 by 5 is 5, one time cancel, one time left, and 9 over 5 you get, 6 3s are 18 over 5 plus 2. When you take LCM, you will get 1 over 5. So now come to the fourth part, 3x square. You take the first derivative, it is 6x. To find the stationary point, 6x equal to 0. So 6 multiply here, shifted at other side, divide, so x is equal to 0. Now you differentiate again. When you differentiate again, you will get 6. So 6 is greater than 0. So f has minimum value, so at x is equal to 0. So 0 you put in the given question, so you will get 0 answer. The fifth one you do it by yourself. Now come to the sixth part. In sixth part you differentiate with respect to x. So what you get? 3 multiply with 3, 2, 3 2s are 6x square, 2 2s are 4x, and minus 36, and 3 is constant. Now for the stationary point, you put the first derivative equal to 0. When you put first derivative equal to 0, 2 is common, you divide both sides by 2, so you will get this function. Now to find the value of x, we differentiate, we solve it by for quadratic formula. So when we solve by quadratic formula, x value, we will get this. You know that quadratic formula, minus b plus minus under root b square minus 4ac divided by 2a. Here value of a is 3, value of b is minus 2, and value of c is minus 12. So when you put, you will get this 1 plus minus under root 55 over 3. Now you take the second derivative of the first function, this one. So 6 2s are 12, 12x minus 4, you will get this. Now in the second derivative, you have to put this value one time the positive value. Two values are given, 1 plus under root 55 divided by 3, and 1 minus under root 55. So first you put the positive value in this second derivative, 12x minus 4 in place of x, and here you solve it, 3 4s are 12, so 4 into this and minus 4, you solve it, 4 under root 55, which is greater than 0. So means that f of x is relative minimum at x is equal to this function. Now you put in the given question this value and solve it. In place of x, you put 1 plus under root 55 over 3. So in the given function, you put and solve it. You take cube here and here square and here constant. So 2, this 3 cube is 27, 2 or 27. So you will solve it by formula a plus b whole cube, which is equal to a cube plus 3a square b plus 3ab square plus b cube. With this formula you open it, and this one a plus b whole square formula, a square plus 2ab plus b square. So consider that the first term is a and the second one is b, and this one simply multiply with minus 12. So you solve it, you will get the required answer, this one. Now again you will check it for the negative value. When you put negative value, you get this. When you put negative value in the second derivative, so you solve it, you get negative 4 under root 55, which is less than 0. So means that f of x is relative maximum at x. So we get 2 point. For x, 1 plus under root 55 divided by 3, we get the minimum value of the function, and for negative 1 minus under root 55 for 3, we get maximum. Now this value you put in the given question and solve it completely in this given question. In this question, you put in place of x 1 minus under root 55 over 3 and you solve it. So you will get this answer, this one answer you will get. So therefore by replacing 55 by minus, we have this for the second function. So means both functions we get, for both value we will get the maximum or minimum value. If it is greater than 0, minimum value. If it is less than, maximum value. Look at the seventh part. If you check the seventh part, you have given x power 4 minus 4x square. So differentiate with respect to x. So 4 will come in coefficient, and from power we subtract 1, so we get 4x cube. And 4 multiply with the coefficient, and 2 multiply with the coefficient, so 8, and from power we subtract 1, we get minus 8x. This is the first derivative. For stationary point, what we will do, 4x cube minus 8x we put equal to 0. So 4x is common, we take it common. X square minus 2, we will find the value of x from this. So 4x equal to 0 or x square minus 2 equal to 0. So x equal to 0 and x square, this minus 2 shifted at this side, it will be positive 2. So x is equal to plus minus under root 2. So we get three value. One is 0 and the other two values are plus under root 2 and minus under root 2. Now we differentiate again the first derivative. The power will multiply with the coefficient. So 12, 4 3s are 12. Power subtract 1, so x square, and minus 8 because dx over dx is 1. So 12x square minus 8. Now in the second derivative, first we put minus under root 2 or plus under, your choice. You can put it plus under root 2 first, no problem. So when we put minus under root 2, so 12 minus under root 2 square, square root, on a negative sign, square is positive, square root cancel 2, so 12 2s are 24, 24 minus 8 16, which is greater than 0. So f is relative minimum at x is equal to, because we get a positive value, minimum at x is equal to minus under root 2. Now we put this minus under root 2 in the given function here. In place of x, we put minus under root 2. So minus under root 2 power 4 minus 4 into minus under root 2 power square. So when we solve it, we will get 4 minus at minus 4. Now we put for x is equal to 0. So when we put x equal to 0 in the second derivative, so 12 into 0 minus 8 we get, which is less than 0. So f is relative maximum at x equal to 0. Now in given function, in the question, we put x equal to 0 and we find that this. Now we find for the third value, second derivative. In second derivative, we put positive under root 2 and we get 16. Again, the function is minimum at this. And in the given question, again, we put under root 2 and we get minus 4 answer. So for the 3 values we solve it. The 8th part you do it just like 7th part and 9th part in the same way. Their methods are same. So question number 3, inshallah, from question number 3, 4 and 5 we will discuss in our next video lecture. Take care. Allah Hafiz.